So graphs of rational functions. So rational just means you have a variable in the denominator. Okay, so let's look at the most basic rational function, and that's just 1 over x. So what I'm going to do is I'm going to I'm going to make a table here. I'm going to plug each of these values in for x and write down what my y value or my f of x value is. So if I plug -5 in for x, I get 1 over -5. If I plug -4 in for x, I get 1 over -4. I'm just putting 1 over each of the x values. And if I put 1 over -1, that's just -1. Now, what happens when I plug 0 in? I get 1 over 0. Well, we can't do that. This is an error. That's going to be a key part of our lesson today. Finding what x value makes us divide by 0. And then when I plug my positive values in, 1 over 1 is just 1. 1 over 2 is 1/2, 1/3, and 1/4. So I'm just choosing a whole bunch of values for x and making a table to try and figure out what does this look like. Now, any value that causes you to divide by 0, that's an error. We're going to make a boundary line going through the graph. That's all the places where x is 0. I've got to block that off because I can't plug it into the equation. Now I'm going to graph -5, 1 over -5. 1, 2, 3, 4, 5. So -5, -1/5 is really, really close to the x-axis. -4, -1/4 is just a little bit further away. -3, -1/3. See, I'm just slowly creeping away here. Now, so what this shape ends up looking like is like this. I can't cross over the x-axis or the y-axis because that would mean that x is 0. So that's why I create a boundary line, kind of protecting that spot. Now, if I go to the positive side, 1, 2, 3, 4. 1 is 1. 2 is 1/2. 3 is 1/3. See how the larger and larger x gets? The y value gets smaller and smaller and smaller. It gets closer to the x-axis. So we're always going to have these types of shapes if you see an x in the denominator. We have what we call horizontal asymptotes. That's as x gets really, really small, what's the graph approaching? Or as x gets larger and larger, what is the y value approaching? So let's look at some different graphs. Oh yeah, let's actually write the vocabulary down. Our vertical asymptotes are vertical lines on a graph that correspond to the zeros of the denominator, and they need to be expressed as an equation, x equals h. Horizontal asymptotes are horizontal lines that tell you how a function will behave at the edges of the graph. So as x gets really, really small, or as x gets really, really big. And those should be expressed by y equals k. So I want you to notice something in these two equations. H matches with the number that's with x in the denominator. K is the number being added to the end. We're going to first find our vertical asymptotes by what make the denominator 0, because this is going to be a boundary line we cannot cross on the graph. Then we're going to find the horizontal asymptote by looking at what's added or subtracted at the end, and we're going to make some graphs. Okay, example 1 just starts by identifying what the asymptotes are. I always just say VA and HA. Vertical asymptotes are the value that make the denominator 0. What makes x minus 2 0? When x equals 2. See, 2 just makes the denominator 0. They must be written as an equation. The horizontal asymptote is always y equals. Vertical always goes with x, with the denominator. So horizontal is always the other one, y, and that's just the number at the end. That's all we do for the asymptotes. Look at letter B. Vertical asymptote, horizontal asymptote. What makes the denominator 0 when x equals -1? The horizontal is y equals the number being added or subtracted. Done. Vertical asymptote. What makes the denominator 0? When x equals 4. Horizontal, y equals, now pay attention, you got to bring that negative down with the 1. The -1 counts. Write down the vertical. What makes the denominator 0? And the horizontal, y equals the number at the end. So that's how we start all rational graphs, is by identifying each of the asymptotes. Now, let's actually look at some graphs. All right, so this says identify the asymptotes in graph. So copy down the first equation. What's the vertical asymptote? It's always what makes the denominator 0. Horizontal is y. All right. So the next thing we do is we're going to graph these. Where is x equal to -3? X is -3. Remember, this is the x-axis. So x is -3 right here. So I'm going to make a vertical line going through the x-axis at -3, because this is what I have to avoid on the graph. The horizontal asymptote shifts everything up or down. So we're going to shift down to -2. So I'm going to make a horizontal asymptote at y equals -2. Now, be really careful here. Where the vertical asymptote we have to avoid, the horizontal is just the ends of the graph, the edges of the graph. Okay, so let's find out where the graph is at. All right, so typically, I think when all else fails, if you're struggling at all, a table is always a good thing. So what I always do, if x is -3 here, I pick the numbers on each side of the asymptote. So I pick -4 and I pick -2. If we plug -4 in for x, and we can find the y value. All right, so we get 2 over, what's -4 plus 3 is -1. So this is plugging it in. This is -2 minus 2 is -4. This tells me when x is -4, y is -4, which is down here. So what happens is I can't cross, as I go to the left, it's getting closer to my horizontal asymptote, and I can't cross the vertical asymptote. So it is in this little corner right here. Now I'm going to plug in -2 in for my x. I get 2 over -2 plus 3 is +1 minus 2. Well, what's 2 minus 2? That's just 0. So what that tells me, when x is -2, y is 0. So I graph this point. So this is in this upper corner. So typically your asymptotes break it into 4 little quadrants, and you see your shapes in one corner or the other. Let's look at another one. So first I'm going to start with my vertical asymptotes and horizontal asymptote. So what makes the denominator 0? This part should not be hard. You should be able to identify your asymptotes relatively easy. Okay, I'm going to erase this table, make a little bit more room. Okay, now I'm going to graph my asymptotes. So where is x equal to 1? Right here. Where does y equal 3? Right here. Now, I'm going to make a table. If this is where x is 1, I'm going to pick a number before 1 and a number after. We're just going to plug points in to find out where the graph is at. If I plug in 0, I get 1 over -1 plus 3. Well, this is just -1 plus 3 is 2. So when x is 0, y is 2, we're just graphing that point of 0, 2. So I can't cross my vertical asymptote, so that means this side is just getting closer. And as I go to the left, as x gets really little, I'm getting closer to my horizontal asymptote. It's just in this corner here. Now when I plug in 2, I get 1 over 1 plus 3. Well, this is just 1 plus 3, or 4. When x is 2, y is 4. 1, 2, 3, 4. This is in this upper quadrant. I'm not super fussy about the shapes, but think of the asymptotes.
J. Coleman, if you're still in the building, please come to the main office. J. Coleman, if you're in the building, please come to the main office. Thank you.
As you get further away, you should be getting closer to the asymptotes. It shouldn't look like that, okay? You should be getting closer to the asymptotes the further you get away. All right, let's look at this one. Vertical asymptote, horizontal asymptote. The vertical is x is -2, y is 1. So now I'm going to graph my two asymptotes where x is -2 and y is 1. All right, now I'm gonna pick some points to find my graph. If x is at -2, let's pick -3 on the left side and -1 on the right side. I'm always just going on each side of the vertical asymptote. And then I'm going to plug that number in. -1 divided by, if I plug in -3, I get -1 on the bottom plus 1. Well, -1 divided by -1 is 1, plus 1 is 2. If I plug -1 in for x, I get -1 over 1 plus 1. Well, that's going to be 0. All right, so let's graph our points. -3, 2. So -3, 2. Now it's up in this quadrant. See how it's up in the top corner this time? So, and I graph my other point, -1, 0. See how this is forcing my shape down in the bottom quadrant. What was different about the equation that you think it's, instead of going in these two, it goes in these two? See, notice both of these graphs, upper right, lower left, upper right, lower left. Those are both positive. This is negative, so it goes in the upper left and the lower right. But we can always use tables to find coordinate points. All right, last problem. Vertical asymptote, x equals 4. Horizontal asymptote, y equals -2. Graph your asymptotes. This is where x crosses through negative or +4. Y is -2 right here. Based on what we saw, if this is a +3, where would you expect to see the graphs? All right. So I'm going to make a little table. It's crossing through at +4. So I'm going to pick the number before, which is 3, and the number after, which is 5. I'm going to plug these numbers in for my x. So I get 3 over 3 minus 4 is -1. This is -3 minus 2 is -5. Now I'm going to plug in 5 in for my x. 3 over 5 minus 4 is 1 minus 2. This is 3 minus 2 is 1. So I'm going to graph the point 3, -5. X is 3, y, -5. See how this is underneath, lower left. Then when I graph 5, 1, 1, 2, 3, 4, 5, 1, this is up above. Make sure you're always going towards your asymptotes. And in the corner here, it's just curved. And that's it.